Hello and welcome to another Zoe's encoding session. How about that? How about that? I bet you didn't expect that shit to happen. Hmm? Anyway, so before I start, I wanted to actually say thank you to Frank, who became a patron on my Patreon with €1. Thank you. Thank you for €1 patronage. I don't know. I don't even know what's the word in this particular case. So, by the way, if you also want to support me, the link to my Patreon is going to be in the description. Don't let the poor Zozin starve to death. Anyway, so today is what? Today is what? I think today is Thursday. It's actually already Friday because it's actually a night, right? But I'm sort of like, I didn't go to bed, so for me it's still Thursday. So I'm recording the Thursday coding session on Friday night, right? So today is a Friday night, and the reason why I'm doing that is that because I tried to do that during the day, and I couldn't do that because my neighbors were fucking celebrating birthday and they were listening to very loud music, and that actually completely ruined the entire recording. And um and it also really upset me, so I was upset the entire day because I couldn't record and I had to listen to very annoying loud music. So I'm gonna try to make another recording of this session. So today is Thursday, as you can see, and that means today, according to the schedule, we are developing our Twitch bot. I'm not streaming on Twitch anymore, but I'm still developing a Twitch bot. So we're going to be working on a technological part of the Twitch bot. So, and we recently started to work on some sort of like a replacement for curl, which is a immediate mode HTTP client library. If you are interested at how all of that started, you can watch the previous VOD, previous IM HTTP mod, so where we started this entire project completely from scratch. And of course, the source code could be found in the description. Both of the links are going to be in the description. So, all right. So what do we have so far? What do we have so far? We have, yeah, we can now make a plain HTTP request, right? So immediate mode HTTP library basically means that it sort of has a similar API to immediate mode UIs, like something like I'm GUI or dear I'm GUI. So essentially in here, I wonder if there's any examples that we can take a look at. Yeah. As you can see, so in event loop, you basically draw everything yourself, right? So you say, okay, we're drawing the text, right? Then we're drawing the button with the label save. And if the button was clicked, we perform a particular action, and then input text is drawn, and so on and so forth. So yeah, that's basically what immediate UI looks like. And as you can see, it can get very complicated and stuff like that. So the main difference between like immediate UI and not immediate UI is that in retained UI, you prepare the tree and then you give it to your library, and it organizes the event loop and occasionally calls your callback and whatnot, right? In the case of immediate UI, you are actively participating in the event loop of the UI. So that's pretty much the main difference. And I wanted to apply this idea to the HTTP library, to the client HTTP library, right? So because there are similarities between the like HTTP client libraries and UI libraries in the sense that you prepare a request structure, you provide the URL, headers, some other stuff, prepare the body, and then you give this thing that you prepared to the library. Library performs the request, then collects the response, and then it gives you the collected response. So as soon as you give your request structure to the library, you lose any control to how the request is done. Similarly to how you lose all of the control of the event loop when you give your UI tree to the UI library. So I thought, why not just create an API, immediate mode API, that makes you actively participate in the HTTP request response handling, right? So essentially, this is how it would look like. You start a request, and you're requesting a particular resource with a particular method. Then you send the headers, and then you say, okay, I'm done sending the headers, I'm sending the body. And then you say, I'm done with the request, right? So I'm actively participating in preparing the request. So then I'm starting handling the response, and I receive the status code, I receive all the headers, and I receive the entire body by chunks, right? So, and then I say I end the response. So as you can see, I'm actively participating in sending a request and receiving a request. So, and I just wanted to see how this entire idea will go. So you sort of like need to know how HTTP protocol works, but you need to know it only on a higher level, right? On a higher level, you need to understand that there is a request and there is a response. There are request headers and there is a request body, and there are response headers and there is a response body, and also response has status codes. And this is precisely what you're receiving, right? You're receiving them in this particular order. Right, but this kind of API still allows you to hide away some of the details of the HTTP protocol. For instance, I think you can implement chunked transfer encoding without changing this API, because we already receive chunks, receive body by chunks. The reason why we receive body by chunks is that because we allocate a fixed buffer. Right, we allocate just a fixed buffer, and we only work with that buffer. So we read whatever we receive from the server into that buffer, and we handle it. Then we throw away, read another chunk, and handle it, and throw away, and so on and so forth. Right. So we already have this sort of like chunked API. Right. So it should be relatively easy to actually add support for chunk encoding transfer. And as a matter of fact, we already hide a little bit of HTTP details away. For instance, our library seamlessly handling content length for you. Right. It already handling content length. So essentially, as you pull the headers, the REST next header actually looks into the headers that you're pulling out, and if it sees content length, it remembers content length, and then it uses that content length in the subsequent next body chunks to determine when to stop reading body chunks. Even though the transfer is not chunked, but it still do that. So as you can see, even though you're actively participating in the details of the HTTP, some of the details still can be hidden, right? You don't have to worry about content length. Nowhere in this code you're actually caring about content length because it's encapsulated inside of the library. So it is still possible to have a pleasant API but still have a control over how exactly the response is handling. You see what I'm talking about? So I think I discussed it a lot in the previous VOD, so I really recommend to just check out the previous VOD where we started this entire library. So yeah, one of the things I wanted to do today, I wanted to implement the chunk transfer encoding, because this is considered one of the I don't know how to say that, one of the challenges in implementing your own HTTP client library, right? So one of them is chunked encoding, right? Another one, I suppose, is keep alive. And another one, I don't know which one another one could be. I don't know, maybe HTTPS, but you can just slap open SSL on top of it and it's going to be fine. So let me know in the comments if you know any other, the main your own client HTTP client library challenges, right? The only ones I know is like chunk encoding and keep alive, and I think we can pull off chunk encoding relatively easily. And another one, keep alive, I think we should be able to pull off keep alive as well, because nowhere in here we imply that after you finished handling the response you have to close the connection. You see, we actually close the connection after we finished handling the response. So that means we can have some sort of a loop here that starts a new request on the same connection. Why not? So I don't see any problems with like implementing something like keep alive, but in case of a keep alive, you will still have to actively participate in the request response handling. But I mean, still. Another one is probably redirects. Okay, so in here particularly, we're gonna have another problem with redirects, but I think I actually discussed redirects in the previous vote. So it's essentially, yeah, at any point you can just go back and start another request. If you, for example, received a redirect code in here, you know a new location, you can just jump back into the request and make a new request in here. So, yeah. Anyway, again, just a disclaimer, I don't know if it's a good idea. Maybe it's gonna turn out a bad idea, and that's precisely why I'm implementing it, because I need to gather more information about that idea and know why exactly it is bad or good. Who knows, right? So I'm just doing the research, okay? So it is what it is, and it isn't what it isn't. So let's implement the transferred encoding chunked and see how difficult it will be to implement. All right. I want to actually refactor my library a little bit. I want to refactor it a little bit. So right now, as I already said, we have fixed buffers, and we try to use only the memory of these buffers. So res meta buffer stores response status and the headers. Actually, it stores them in the form of a text. Right, so it basically stores the entire section starting from the beginning of the response up until /r/n that manifests the start of the body. Right, so this entire thing is located in this specific buffer. Right, and in here we actually store response body chunks. Right, we store response body chunks because we have a fixed buffer and we still need to read it by chunks even though the transfer encoding is not chunked. So I want to refactor that slightly. I want to introduce another buffer in here that I would call a rolling buffer. So I've been thinking about this library the entire week essentially. So I work on this library once a week, and throughout the week occasionally when I'm just eating something and drinking something or in the shower, I'm thinking about how to implement this entire thing, and I came to a conclusion that we need some sort of an abstraction that I would call like a rolling buffer or something. I don't know, like a buffer queue, but usually when we talk about queue we mean a data structure that stores elements of the same size, but in our case this sort of queue is going to be like continuous. It's a queue of characters, and the characters are chunks of different sizes, so it doesn't really fit to the definition of queue being a queue of elements of the same size, right? Essentially, so you have this buffer, right? You have this sort of queue buffer. Maybe it's going to be a queue buffer, I don't know, but I kind of like a rolling buffer idea. So essentially you want to handle something from the server, right? You want to handle something from the server and you ask, please read something from that server. Okay, so we read this something from the server and we filled in the buffer to this particular mark, right? So then we realized that we read, for instance, all of the headers, right? And body starts somewhere around here, right? Body starts somewhere around here. Right, so this is what we realized. Okay, what we can do, we can handle this entire thing, and then we want to throw away this chunk. So we need some sort of an operation that would allow us to actually shift the entire buffer by this size. Basically, bring this entire chunk to the beginning here, right? So, right, let's actually put it like that. So, and this entire thing is going to be somewhere here. So it will literally take it and move it to the beginning, right? And then you can say, okay, top off the buffer even more, read more things, and there you go. You read more things, right? You read more things, and then realize, oh, okay, so this is where the chunk begins, and this is where the a transfer chunk roughly ends. We're gonna handle it yet again, and we're gonna shift it again, and you can just keep sort of like reading things and handling things and throwing them away. Right, so some sort of like a rolling buffer. For some reason I want to call it a rolling buffer, but it's sort of like a queue. But at the same time, it's like rolling around. And for this kind of thing, we need two operations, right? The first operation is shifting everything up until particular point. So we choose the point, and we starting from that point, we shift everything to the beginning. And another operation is like top of the buffer, just read a little bit more into it, as much as you can, right? Maybe it will be able to read until the end, maybe not. It just depends, because it's a network programming, you never know. And TCP is a stream protocol, so it's just like it's meant to be handled like you're reading a file, right? So you never know where things end or start or anything, so that's why you need this sort of like rolling buffer, which makes it kind of difficult to work with TCP, but it is what it is, and it isn't what it isn't. Right. And another interesting thing is that we should never give the user of the library pointers inside of this buffer. It should be purely internal buffer, right? Because again, it's constantly rolling around. The data is moving like from right to left constantly, right? And if you try to give it the pointer to this buffer to the user, like outside of the library, it may get quickly invalidated. It can get very quickly invalidated. Get invalidated very quickly. English is hard, I'm sorry. So that means this has to be only a temporary buffer. Right, and things that needs to be given to the user should be moved into like separate, more stable buffers, if you know what I mean. Right, so the lifetime of the things inside of this buffer is very, very short. So we need to be very considerate of lifetimes of this entire stuff. So yeah, we need to implement these abstractions, and as we implement this abstraction, I think it's going to be a little bit easier to implement chunked encoding. Right. I think it's going to be a little bit easier to implement chunked encoding. Hopefully whatever I explained makes sense. Anyway, so let's start. So we already kind of have a rolling buffer behavior in here. Like for instance, when you start the response, you read as much as you can into the response meta, right? Then you find the end of the meta. Meta is basically status codes plus headers, and everything after that you move it into the response body chunk, and as you read chunks, you basically return what you have in that body, and then remove everything and read again. So it's already res body chunk already acts like a rolling buffer, but it's actually not. So the problem with this res body chunks is that we give pointers to this buffer outside of the library, right? We give pointers outside of the library, and that is very dangerous because it has to be constantly moving around and stuff like that. So we need to introduce like a special rolling buffer. How are we gonna call that? How are we gonna call that buffer? That's a good question. So maybe it's gonna be called something like input buffer.
Monkas.
Thank you, good for 22 months of tier 1 subscription. Thank you. I'm not live, by the way. He totally subscribed offline. Alright. Thank you so much for the resub, poggers. I'm actually recording right now. I'm pretty sure he knew that. I'm pretty sure he knew that and basically planned that all along. So yeah, cheers. Thank you for your sub. I know. Sure, he didn't know. Sure. Sure. Go. All right. So what we're gonna call in here, rolling buffer, right? I'm HTTP rolling buffer capacity. Rolling buffer capacity. Again, so I'm not messing with my streaming setup. I'm using my streaming setup for offline recordings, and that's why I still have alerts on and stuff like that. So that's why. Yeah. So thank you so much. Thank you. So here's the rolling buffer, and we also need to know the size of the rolling buffer. Maybe I should call it rolling buffer. Why not? So rolling buffer, HTTP rolling buffer capacity, and let's put it in here. Rolling. It doesn't want to autocomplete because it's G. And the size of this entire thing, I think we can, yeah, we can actually keep it like this. We can actually keep it like this, and like this, at least I suppose. All right, so let's have a couple of operations. So the first one is going to be I'm HTTP rolling buffer. Let's call it shift rolling buffer, right? So, and in here is going to be I'm HTTP, and we're going to provide the end at which you want to actually shift things around. So let me show you what that means. Oh shit. I accidentally closed it. I actually wanted to press a different combination of keys, but yeah. All right, so this is the buffer. This is the buffer, and you have a chunk of data, right? So you have a chunk of data, and then you want to shift starting from here. So you want to shift this thing to the beginning. So, and this is what I call the end. Right, so this is the end that is going to be shifted to the beginning. So, and we pass this end as a pointer inside of the buffer. So one of the main things in here that we need to check is that end is actually greater or equal to the buffer, right? You cannot put an end before the buffer because it's invalid, right? So we need to basically do boundary checks, right? So we're doing boundary checks. So after that, we need to know the size of this entire chunk, like the size of this entire chunk that we're essentially removing, right? So let's just call it like this. It's going to be something like, yeah, essentially you're just subtracting a rolling buffer from the end, and that gives you the whole size. And another thing that we have to absolutely check, the size of this entire thing should be less or equal, right? It should be less or equal, I guess, to the current size, right? So it's going to be HTTP rolling buffer size. Yeah, I actually didn't call it size, fortunately. So this one is a size. There we go. So essentially, this is how we check that the end is within these boundaries. So this is how we check that this end is correct, but it might be incorrect. Right, so we have to be very careful in this case. So after that, I need to do a memory move. Right? I need to move. The destination is going to be I'm HTTP rolling buffer. This is where we move and everything, and end is the source. And now we actually need to move this amount of data. Well, this amount of data is actually equal to the whole thing minus this thing. So that means we have to move I'm HTTP rolling buffer size minus n, right? And after that we need to update a rolling buffer size and subtract n. So to be fair, it would be just easier to do it before memory move and just use the new size of the buffer. There we go. So this is how in 5 lines we implemented shift rolling buffer, right? So this is how you shift everything. And we also have a boundary check. So if you put an incorrect pointer in here, it's gonna crash. And can your Rust do that? It can. It can automatically generate that code for you. Okay, so this is the first thing, and I want to actually mark it as static. And so the next one is going to be try to read as much as you can, right? Try to read as much as you can. Basically, top the rolling buffer. So it's going to be something like I'm HTTP top rolling buffer. I'm not even sure if it's a good name for such function, so you're just basically topping the rolling buffer. I don't know. I don't know how to call it. HTTP. Okay, so, and I'll put static in there. So it's a little bit cold in here. So I think I'm gonna quickly put on my programming socks. Just a second. I'm gonna pause the video, but in a snap, the programming songs are gonna programming socks are gonna be on me. If that makes any sense. I don't speak English. I'm sorry. Okay, I'm back. So finally, warm feet. Okay. So now we need to top the rolling buffer. So we need to read a little bit more data from the network. So we read things by calling to this function like this, right? So we provide the socket and we provide the buffer into which we are reading. To be fair, we have to be reading into the end of the buffer. Right, we have to be reading into the end of the buffer. And here is an interesting thing. What if the buffer is already full? Should we try to read it? Maybe we shouldn't. Right, maybe we shouldn't. So only if I'm HTTP rolling buffer size is sizer? Really? Did I call it sizer? Okay, so I didn't try to even compile my code. Alright, so sizer, if it's less than I'm HTTP rolling buffer capacity, only then we're trying to read this entire thing. Okay, so we're starting to read from rolling buffer plus I'm HTTP rolling buffer size, right? And how much do we read? We read the capacity, rolling buffer capacity minus the rolling size, right? And here's another thing that we need to be aware of. The size has to be less or equal to the capacity, but we already checked that with this condition, so I think it doesn't really matter that much. All right, so and after we're done, we can also assert that n is greater than 0. If it's equal to 0, that means something went wrong, and maybe we can do something like to do, saying that HTTP top rolling buffer does not handle read errors. Right, there we go. We have something like this. HTTP rolling buffer size plus n. There we go. So it's going to be plus n. So that's pretty much it. I have nothing much to say. Right, if the buffer is completely full, we're not going to even try to read it. Right, so we're going to completely ignore that call. If we have a little bit of space, we're going to read as much as we can into that buffer. And if error happens, we're going to just assert that because we don't really care about it right now. So yeah, these two operations I think are going to be extremely useful. I think they're going to be extremely useful. So I kind of want to refactor the current code to use these two operations. So when you start the request response handling, I want to read like a top a rolling buffer. Then within the rolling buffer, I want to find the end of the metadata at the end of the header list and stuff like that, and then copy it into the like a request thingy. Copy it into the request thingy, and then leave the rest for the body. I think it's gonna be interesting. All right, so let me try to compile this entire thing because I'm not sure if it's gonna compile or not. So do we compile? No, we don't compile in this case. Okay. So yeah, so these functions are unused essentially. That's the main warning in here. So I also want to have another function. that basically takes a rolling buffer as a string view, because you usually want to like top the rolling buffer and parse it a little bit, so you know where to like where you have the end around which you have to shift, relative to which you have to shift, I suppose. So let's do something like this. It's going to be string view I'm HTTP rolling buffer as SV, as a string view. So it's going to be something like this. I'm HTTP, and here we're just returning string view, right? And the data is going to be equal to I'm HTTP. Oh boy, rolling buffer, right? Rolling. This one is size, as you can tell. So there we go. We have a string view, and yeah. So essentially, what we can do, we just top the buffer, and then we get the current rolling buffer as SV. We parse it a little bit, and then once we finished parsing, we shift it, and the end upon which, relative to which we want to shift, will be clear after you parsed with string views. I'm going to actually demonstrate it a little bit later. Okay, so let's try to recompile this entire thing, and everything seems to be working. Everything seems to be working. Okay, so let me take a look at the response. How do we start the response? All right, so this is where we sort of start all of this stuff. Yeah, so as you can see, we kind of already have like a rolling buffer functionality, and yeah, this is the reason why we had a spring. Yes. So essentially, I had this like the entire spring back meta function just to accommodate the fact that I need this rolling buffer functionality. I think if we incorporate rolling buffer in here, we essentially won't need this kind of thing anymore. Yeah, I think I picked up the right abstraction. Okay, so let me separate this entire thing, and the thing I'm gonna do I'm HTTP. So top rolling buffer, right? I'm HTTP. Top rolling buffer, and after that I need to take the rolling buffer as as a string view. So let's call it rolling. I am HTTP rolling buffer as SV. I'm HTTP. There we go. So what I want to do in here is essentially find where this thing ends. How can I find where this thing ends? Well, essentially I can start iterating it line by line. So while a rolling count is greater than 0 and while it's greater than 0, I'm going to try to extract the line, right? So the line is going to be a switch shop by delimiter, and delimiter is going to be a new line, right? So, and since the body starts at /r/n, we have to stop. We have to stop if the line is equal to /r, right? We have to stop if it is equal to /r. Right. So that means this is where precisely the body is located. I mean, yeah, so this is where precisely body starts. So what we need to do in here, we need to now take the entire thing, right, the entire thing that we found, and copy it into the res meta buffer, right, into this thing, right? We need to copy it into this thing. So it's going to be mem copy. The destination is going to be HTTP res meta. The source is going to be rolling buffer, I suppose. So I'm HTTP rolling buffer, right? It's going to be a rolling buffer, and the size that you want to copy in there is actually I suppose the rolling data minus rolling buffer. Yeah, rolling data minus rolling buffer. So there's a couple of assumptions that we make in here. Again, we need to make sure that this data is a correct thing. So we are asserting that rolling data is greater or equal to rolling buffer, right? And also maybe we want to actually calculate the size of this entire thing, right? So it's going to be something like this. So here is the size, and the size of this entire thing has to be less or equal than HTTP rolling rolling buffer size, right? So that's what we have to have in here. And another interesting thing is that maybe also n should be less or equal HTTP res meta capacity. So basically we need to ensure that this entire thing fits there. So here we just perform the boundary checks, right? So this is just the boundary checks, and this is basically if it's gonna even fit in there, because it might be too big, right? After that, the HTTP res meta size becomes equal to n, right? Which is kind of interesting. Maybe we could inline the n, but I think it's all right. It's all right. So, and then, yeah, meta cursor is actually needed to parse, like progressively parse those things. Just to progressively parse those things. But since we need to have that to progressively parse those things, can we just... Can we just get rid of the res metadata? So essentially, every time you call, for example, like status, right? Every time you call status, or like header, like every time you call header, we top the buffer and parse a little bit more. Top the buffer and parse a little bit more. We don't need like intermediate res metadata. So, but that will actually result in constantly invalidating the headers. So what you have to do, like if you iterate through the headers, you cannot iterate them the second time. But maybe that's okay. So basically, if you want to iterate them the second time, you have to save it yourself somehow. Right. So essentially, once you iterate through them, they're gone forever, right? That's a very interesting idea. That will actually simplify a lot of things. That will actually simplify a lot of things. My God. And it will help us to get rid of all the things. So you just have a rolling buffer, and you need a status. You just top it off, make sure that something is there, and we chop off the status and we give it to the user, and yeah, it just makes it easy overall. I really like this idea. So, and because of that, I think we don't even need to do anything. So if you start the response, you really don't need to do anything except like resetting this content length state. So you don't even need to top anything, because we're gonna top in the corresponding status code and headers and so on and so forth. That is so cool. That enables us with like getting rid of the res meta cursor and all of this stuff. It just makes everything easier. So I think I picked really the right abstraction. And maybe this kind of abstraction will help us to implement the chunk transfer like easier. I really like that. My God. Okay, so maybe that's precisely what I'm gonna do. Let's just remove this entire crap and start rolling. Yeah, and start rolling. This is precisely why I implement these stupid ideas, right? Because you get to discover these like small little things that sort of fall in places, right? At the beginning it feels like really clunky, but as you go further and further and explore this domain of the problem, oh, okay, you start to realize like these things. Right, so you don't need to like keep this intermediate thing in here if you have this rolling buffer. So you get to find a right abstraction that just falls into into places. It's really hard to explain, but that's precisely why I implement these stupid ideas, because sometimes they turn out quite interesting. Not necessarily useful, but sometimes it's actually pretty cool. And maybe, by the way, maybe we don't need that, maybe we don't need that, maybe we don't need any of this shit. Maybe the only thing that we need is a rolling buffer, of course, content length, because we need to take it into account, and a special buffer, something like user buffer. So it's going to be IMHTTP user buffer capacity. And essentially, user buffer is going to be a space into which we put the data, the pointer into which we give to the user. Because again, the lifetime of the stuff in a rolling buffer is very short, everything is just moving around. So to not lose the data that we want to give to the user, we're gonna basically copy the chunks of that data into the user buffer and then give the pointer to the user buffer, right? So yeah, that way, for example, if you want to handle status code, right, maybe I can draw that. So this is going to be rolling buffer, right, roll, and this one is user, right. The thing about the rolling buffer is that you have the status here, status, then a bunch of headers, like here is the headers and so on and so forth. So essentially you would identify the end of the status, right, and you want to shift the whole buffer and read a little bit more. So before you do that, you copy the status into the user buffer. So this is going to be stat, right? And then you shift everything. And only then you essentially shift everything and move into the end. And as you can see, if you shift it, it actually like you lose this data. But since we copy it into the intermediate user buffer, it's not gone until user actually handled it. So yeah, we essentially have two buffers, like a rolling buffer and the user buffer. So we identify the chunk in the rolling buffer, we put it into the user, and we shift everything and give this thing to the user. So yeah, that's actually a pretty interesting idea. So then, do we need to have like a user buffer size? Because we're going to be giving the user like a string view usually. I don't think so. I think we can keep it just like that. All right, so let's actually try to recompile this entire thing and see how miserably it fails. Okay, we don't have this entire thing. So let's go to fine. So maybe initially it's going to be equal to that, and the user buffer is going to be equal to rolling buffer. Yep. So do we have any things in here that we want to actually check? I don't think it matters that much, but I guess the user buffer should be less or equal than the rolling buffer. Or maybe the other way around. Maybe the rolling buffer should be less or equal than the user buffer. Because whatever you have in a rolling buffer should fit into the user buffer, because maybe the thing that you want to put into the user buffer is the whole thing. So yeah, the user buffer should be at least as big as the rolling buffer thingy. Yeah. The user buffer should be at least as big as the rolling buffer, because sometimes you may want to put the whole rolling content into the user buffer. I think it does make sense, right? So yeah, okay. So right now they're equal, but maybe at some point it's going to change. So it's quite important to document this assumption. It's quite important to document this assumption. Okay, so when we don't even need Spring Back anymore. Like, this concept is completely useless, right? And this concept is actually explained in the previous vote, so check it out. Okay, so now you need to read the status code, right? So to read the status code, what do you essentially do? You just, yeah, let's actually separate the old version and whatnot. So I'm HTTP top rolling buffer, we just top it, right? And if it's already full, it's going to be completely ignored, so there's nothing wrong in here. And then I'm taking the rolling, right? I'm taking the rolling. I'm HTTP rolling buffer as SV. There we go. And what I want to do is I want to grab the status line. And to be fair, the rest of the code is this, so I need to take the rolling and chop it by /r. So, and yeah, so this is not /r, /n. Then we skip the HTTP version, and then we get the code. Right, and then we get the code, and then we return this entire thing. One of the things I would like to check in a status line is that it ends with /r. If it doesn't end with /r, that means our buffers are too small. So yeah, basically our buffers are so small that they couldn't fit the status line. That's how small they are. So let's do something like this. It's gonna be status. I think SV ends with, yeah, this is what it has to be, ends with. So status line in this particular case has to end with /r, and if it doesn't, right, if it doesn't, the rolling buffer is so small. Can we just put it like that? That it could not fit the whole status line. So can we put it like or maybe maybe the status line was not fully read after the I'm HTTP top rolling buffer above, right? So that could be the things that happened. All right, so it has to end with /r, and if it doesn't, one of these two things has happened. Okay, after that we essentially skip the version, and then we get the code, and then we just return it. So after that, I think we can quite safely shift the whole status line, right? We can quite safely shift it, because the only data that we need to return in here is the code, and we already parsed it. So the question is how we're gonna shift this entire thing. So status line, so rolling was chopped. Aha, I see. So essentially it has to be shifted as HTTP shift rolling buffer and HTTP by rolling data, because after this chop, the data of this string viewpoints at the end that we need to chop. Okay, so this is actually perfect. Everything falls perfectly in places. I really like it. I really like how everything falls in places. It's actually kind of sus, not gonna lie. Why everything falls in places so nicely. Okay, so what's the next thing? This one has to be SV. All right. So next header. Okay, so the next header could be also simplified. Next header is going to be essentially this thing as well. It's just like we're going to parse it slightly differently. And then it's going to be string view header line. Let's actually call it header line. SV chop by delimiter rolling /n. And what's interesting is that you can actually view this thing as sort of like a bracket. So this is where you chop the rolling buffer, and this is where you sort of shift the rolling buffer. So I think you can just put sort of these brackets in here logically, right? You can put these logical brackets. But I'm not sure how useful it is, because yeah, here this is where we chop it, but maybe I'm not sure if it makes much sense. Yeah, let's not put it. Okay, so here is the line, and of course, again, you can then take this entire rolling thingy and shift the buffer. All right, and the header line. Oh, and again, so if we need to check if it ends with /r. So maybe this is one of the things we can do in here too. All right, so we're gonna check it like that, and the rolling buffer is so small that it couldn't fit the whole header line, or maybe the header line was not fully read after the. But we're constantly like topping off the buffer, so it should be read. Like it just must be read. And interestingly enough, I think this is the time where we need to copy things into the user buffer, right? Because we'll need to give the pointer to the strings to the user, right? We'll need to give the pointers and stuff like that. All right. So we have a header line, and what I want to do here, I want to copy I'm HTTP user buffer, and what I'm copying here is that I'm copying header line data and then header line size. It's actually count. So there we go. This is actually count, and you know what's cool is that I now can perform a switcheroo. So I can just take my header line data and I can assign it to user buffer, and there you go. This variable now now points at something in the user buffer, so we don't have to worry about that. So, and after that you can just shift your rolling buffer, and yeah, so all of that should be probably abstracted away with convenient functions, but the idea is pretty straightforward. So it would be even kind of cool to sort of give string view to this function, and what it will perform, it will detect that string view is within the rolling buffer, it will move this chunk of data into the user buffer, then shift the rolling buffer and give you back the new string view sort of moved into a different buffer. So basically what we're doing here, we're transferring the ownership from one buffer to another one. This is actually very interesting. It's extraordinary idea. Extraordinary idea. Anyway, so how can we even do that? How can we even do that? But maybe not for now, maybe it's gonna be later. But if we manage to do that, some of this code is gonna be actually greatly simplified. But anyway, so there we go. We transferred the ownership, right? So we transferred the ownership. So maybe we can do something like this. Transfer the ownership of header line from rolling buffer to user buffer, right? So we're copying the data of header line to user buffer, and we're changing this thing, and then we're shifting the rolling buffer, effectively destroying the data. That's why we needed to transfer the ownership. So after that we can just perform this kind of stuff. So this is going to be header line. If it doesn't end with /r, we're just chopping it like that, right? So we're trimming everything, and we're returning it back via name and value. And since the header line is owned by the user buffer, these values will survive this call, but they're going to be invalidated on the next header call. Yeah, so essentially they will survive, but they're going to be invalidated, so we have to be careful about that. We definitely need to be careful about that. So document that this thing invalidates name and value on the next, on the consequent HTTP calls, right? So we need to document that for sure. And this entire idea of transferring like ownership of a chunk in rolling buffer to the user buffer is actually needs its own function. This is actually very interesting. Okay, so let me see what we've got in here. So this is a status line undeclared. Oh, this one, because this is because it's a header line. And okay, so next one. All right, so next we're reading body chunks, and I think reading body chunks should be now easier, right? It should be now easier because you essentially just do I'm HTTP top rolling buffer. It's going to be I'm HTTP. So you top the buffer, and you need to actually take everything and yeah, essentially you just need to take everything, subtract from content. Oh, well, yeah, you have to be super careful. So maybe this is one of the things we're gonna put in here. So then, if the content length is greater than 0, right, I think it does make sense. If the content length is greater than 0, we're going to try to do all of these things. We're going to top the rolling buffer, but it's not, I'm going to just return false without even trying to do anything. So we top in the rolling buffer, and we're going to try to do the following thing. We're going to assert if the size, we might as well actually take the string view rolling, right? It's going to be I'm HTTP rolling buffer as SV, I'm HTTP, there we go. And I need to assert that the rolling size is less or equal than I'm HTTP content length, right? So, because otherwise there's something wrong with the server. Maybe the server is sending some malicious data, and we don't really want to handle that right now. Yeah, so this is precisely what we're doing in here, actually. I might as well actually take this entire thing and just put it in here. So MHTTP doesn't handle the situation when the server responded with more data than it claimed with content length. That's, I already sort of predicted that this kind of thing will happen. Okay, and now what I want to do essentially, I want to move the ownership of this entire thing to user, and just, yeah, just use the user. Just use the user. So let's do that. So it's going to be mem copy. I'm copying to how is that called? It has to be called the user buffer, right? And I'm copying it from rolling data. And how much do I copy there? I'm copying rolling size, right? I'm copying a rolling size, and one of the things that we probably want to assert in here is that assert a rolling size less or equal HTTP user buffer capacity, right? And after that, I'm going to be oh boy, so we're checking if the chunk was assigned. All right, so we transfer this entire thing, and if chunk was assigned, we do chunk data, we point it at I'm HTTP user data, right? I'm HTTP user data, the count has to be the rolling size. And after that, we need to shift this entire thing. It's going to be I'm HTTP shift rolling buffer, I'm HTTP rolling data. There we go. So, and after that, I suppose we have to return true. Right, we're returning true. And that's pretty much it, I think. I think that's pretty much it. So we check that we have content length, we top the rolling buffer, we get the rolling buffer as distinct, we check that the whatever we have in the rolling buffer is less or equal to the content length, otherwise the server just sent more data that we don't care about. And also we check the rolling size is less than the user buffer capacity, just in case. And then we copy the entire thing into the user buffer. If the chunk was provided, the pointer to the chunk was provided by the user, we set everything accordingly. And this one has to be count, of course. And then we shift the rolling buffer accordingly. So that should be it, actually. So this one is a count. Not that difficult to fix. What else do we have in here? Comparison of integer with the different signers. Okay, the content length is... We know for sure that content length is actually greater than 0, so it should be relatively easy to convert it to size t. Right. So we know for a fact. So thank you so much, C. And I fucked it up. Nice. Status code 0. Cool. I already fucked it up. I wonder why. So status code 0. So I did something wrong with the status code. We can actually go into the debugger and just try to see what's going on in there. I think that will be a pretty good idea. But overall, this entire thing at least compiles. At least compiles, yeah. Do we build with the GDB? No, we don't. Let's rebuild with the GDB. And there we go, there we go. So maybe I want to go to a TX. It's going to be I'm HTTP. How is it called? I'm HTTP. Okay. And let's do GDB main, right? And let's break on this function, because this function is not supposed to return like empty code or anything. Let's break on here and let's just run this entire thing. Alright, so I top the buffer. Let me take a look at the buffer. So HTTP rolling buffer size, it is 6. Okay, so we do have something in there, which is already nice. And yeah, as you can see, here is the whole data. Right, then I take a look at the rolling and I take a look at here. So it seems to be like, it seems to be working. So then I take a look at the status line. Right, so here is the status line. Looks fine. So then we chop by delimiters. And okay, so then I take a look at code SV. And code SV looks all right. So here is this thing and 3. And then I want to take a look at the HTTP rolling buffer. So here is this data, and after we shift it, I'm going to do an HTTP rolling buffer, and it actually got shifted, right? It got shifted. So and then if I take a look at code SV, I see. Yeah, I see now. Again, the ownership and stuff. So the code SV was still pointing at rolling buffer, but after we shifted it, it actually shifted everything. So I see. Okay. All right. This is actually very easy to make a mistake on, so it's very error prone. So I suppose the ownership of this thing has to be transferred like immediately or something. But how are we gonna make the transfer of the ownership? That's a good question. It could be actually done, I don't know, by the actual shift or something. Right, essentially we can shift, right? So one of the things the shift can make, right? One of the things the shift can make, it can automatically copy that piece of data to the user buffer. Right, it can automatically copy it, and then you can just parse it within the user buffer and just give the pieces to the user. I think it would be actually a little bit better. Maybe that's how it has to be. So is it going to be a useful paradigm? Let me think. Let me think. So this is going to be a shift, right? And instead of void, it may return actually string view, automatically pointing to user buffer. Automatically pointing to the user buffer. Okay. So it would be actually nice to have like a little bit more control. You know what I mean? Because what if you want to have a couple of consequent shifts? What if you need a couple of consequent shifts? How are you gonna handle all that? Maybe a couple of consequent shifts will append the value to the user buffer. They could append the value to the user buffer. Yes, they could do that. Which is rather interesting, I think, because it sort of turns the user buffer into a linear allocator. And the consequent calls have to actually clean the whole linear allocator. This is rather interesting. I think I want to make a cup of tea. And yeah, once we have a cup of tea, we can actually think that through, because it is very, very interesting. Right, essentially this system of rolling buffer and the user buffer become very, very interesting, because like operation just automatically takes a chunk and appends it into the user, takes a chunk and appends it to the user. But maybe if you want to have more control of that, I don't know. Yeah, and that means on every IMHTTP call that does something with the user buffer, you have to clean up the user buffer. You have to set user buffer size to 0, and you have to not forget to do that. Fair enough, I suppose. Fair enough. All right, let's make a cup of tea. All right, I'm back. Champion of the tea. So I think I want to do that, actually, boys and girls. I think I actually want to do that. I want to transfer the ownership automatically inside of the shift rolling buffer. I think it's going to be very beneficial. So you provide the end, right? You provide the end. It copies this entire chunk into the user buffer and shift everything, and then it gives you a string view into the user buffer. I think that's a cool idea, and it will help us to do this thing immensely. But in terms of if you have several consequent shifts, I think maybe several consequent shifts can override the user buffer without, like, instead of appending it, and then we'll see if we'll need to append it, because right now we don't really need to append anything. And I just don't want to implement something that we don't need right now, just because maybe we'll need that in the future. No. Let's implement the things that we only need. All right. Okay, here is the stuff. So we figured out the size of this entire thing, and the first thing I want to do actually is also assert that the n is less than IMHTTP user buffer capacity. And yeah, so here we perform the boundary checks, right? So this is basically boundary check. Check if the chunk fits into the user buffer, right? So, and I don't know, copy chunk to user buffer. It's gonna be mem copy and I'm HTTP user buffer. We're copying it from the I'm HTTP rolling buffer, right? Rolling buffer. And how many things we copy in there? We're copying exactly n, and we already checked everything, so doing that is relatively safe. Doing that is relatively safe. Okay, so we copied everything, then we're shifting everything around. So we're updating the rolling buffer size and so on and so forth. And this next thing, okay, so shifting the rolling buffer. And then I'm going to return a string view, right? I'm going to return the string view with the data pointing at the user buffer, so user buffer, and the count equal to the n. Look at that beauty. So there we go. So the shift not only shifts everything, but it actually transfers this data into the user buffer and gives a string view on that user data, so we can safely parse all of that. Beautiful, beautiful. Sometimes maybe that means that we can use user buffer as an intermediate buffer, and maybe because of that it should not be called the user buffer. The only reason why it's called user buffer is because we're sort of allowed to give pointers to this buffer to the user, because it lives a little bit longer than the rolling buffer. But maybe it should be called something like an intermediate buffer or something, but I don't know. Anyway, so we need to restructure everything according to this thing. So here is the status, right? So essentially we take the rolling thing and we chop it by that, and we check if it ends with R and whatnot, right? We check it if it ends with R. And the next thing I want to do, is something like status line, equal to I'm HTTP shift rolling buffer rolling data, right? And that creates like a new status line. That is already moved into the user and whatnot, and you don't have to shift it anywhere here, right? So we get the rolling buffer as SV, we chop everything by that, and then we check that everything's okay, and we're like, basically this is essentially transferring this entire thing. We know for a fact that it starts. Okay. All right, looking good. So I want to double check if this entire thing compiles. Seems to be compiling. Okay. So, and as you can see, we don't need to do any of this transfer and ownership. So now, oh yeah, so essentially, yet again, this becomes transferring the ownership. Yes. Here we're transferring the ownership, and here we're transferring ownership yet again. And this one is rather interesting. Okay, so there is definitely a problem with the chunk and body, but maybe I'm not gonna care about chunk and body right now, because I can easily just comment it out. Right, let's just easily comment it out like this and see if status and headers work. So let's just run this entire thing, and okay, status didn't work. So at least we've, I mean, the headers didn't work, but at least status worked, which is already nice. All right, let's see what's wrong with the headers. So we top the rolling buffer, we take it as a SV, we chop it by /n, and then we're sort of transferring this ownership. But I don't quite understand why it hangs. I don't understand why it would hang in there. And the question is, where precisely does it hang? Okay, so let's actually try to debug this thing. I'm gonna go to GDP and it's gonna be main, and we're gonna break in here and let's just run this entire thing to enable. Oh, it fails precisely at top rolling buffer. That's very interesting. Why does it fail there? So it fails, like it hangs on read. It hangs on read. Is it because it tries to read the whole thing that we provided, but it can read like less if it wants to? So does it wait until it reads the whole thing? No, it shouldn't, otherwise it wouldn't work. I mean, it definitely doesn't, because otherwise my other applications wouldn't work. So, okay, one more time. One more time. Hey, one more time. We're gonna celebrate. Ew. Okay. So, let's just run it. And I'm gonna step into this thing. And of course, I may take a look at what is the... I don't know. Print, can I don't even know if I can just copy paste this thing in here and just print it. So maybe I want to take a look at the size of this entire thing. Size of the buffer. Print I'm HTTP rolling buffer size. Right, and it's that. So okay. Alright, and it hangs. It literally hangs in there, and I don't know why. Excuse me. Why does it hang in there? Oh, because there is no more data in... Oh, I see. I see, because there's no more data in there, and it's gonna hang until it receives at least something. Right. Fuck. Okay. That is very interesting. But to make this kind of stuff work, I guess we essentially, because we just read everything. We just read everything in one read, the whole response. And we keep topping it up, but to make it stop topping it up, like we either need to make it asynchronous, right? We either need to make it asynchronous, or basically, if you have something in a buffer, if you still have something in a buffer, don't try to top it until you process it completely. You know what I'm talking about? Yes. So it could be one way to fix it. It's kind of like a Pepega way to fix it, but I cannot come up with anything better right now. So let's actually see. Right, so essentially we're gonna do a different condition. I'm HTTP rolling buffer size if it's only equal to 0. That's a really Pepega solution, but I mean, I cannot come up with anything better. And as you can see, it kind of worked to some extent. It actually continued reading shit, which is very interesting. That means our header handling is not correct. So where is my header? I'm HTTP. I'm HTTP response next header. Let's find this thing. All right, and if we encounter a header line that is precisely equal to this thing, we just return false. And that is really weird, so that means that didn't work. So let me take a look. Nothing much to say, to be fair. Like, what the hell? What am I missing? So it read everything. It read the code, it read the headers, it read them correctly. And it also tried to read the rest of the stuff as headers. So it means like it just never encountered that thing. That's basically what it means. It just never encountered it, which is really weird. I don't know why. So maybe we can try to print this entire thing like this, svfmt, right, and it's going to be svarg, and just print the header line like this, right, and let me see, and at some particular point, all right. So, but here it is. Here's the line, and it just didn't recognize this thing as the new thing or /r or something. So, I'm confused. Like, what the hell? So it was never equal to that, but what is this then? What is this then? Okay, so I'm just gonna print out something like this. Right, and it's gonna be 4 size T. Header line count plus I. Right, it's going to be print f d and header line data, and in here is going to be just like this. Just want to, well, there's no new line in here, but maybe there is some sort of a space. Okay. Oh, come on, I can do that. All right. So, all right. So it contains also the new line. Why does it contain the new line as well? Oh, I think I know why does it contain a new line. Yeah, I think it makes sense. Alright, I do agree with that. That makes sense because it overshoots the, okay, so yeah, I just something have changed and I just didn't expect it to end like this. Yeah, so now it should be equal to that precisely, and still doesn't work. /r/n, yes, /r/n. Finally. Shit. It's the most painful thing. It's this kind of shit. All right. I'm not sure if it's correct. I'm not sure if it's fully correct. I guess it makes sense. Yeah, I guess it makes sense. Okay, we have that. Now we need to learn how to read the body. All right, so we're taking the rolling buffer. If it's less the content, we do that. We don't have to do any of this stuff, but I suppose we can just take the entire thing. Right. Let's call it a result, I suppose. Let's call it a result. And result is going to be I'm HTTP rolling like shift, right? And I'm shifting like the whole thing, right? So it's going to be I'm HTTP rolling plus I'm HTTP rolling buffer size. Rolling buffer size. So I'm just taking the entire thing, and then if you have a chunk, we're going to reassign this entire chunk in here. And we should not forget to do something like this: content length minus result count. Right, so we're subtracting this entire thing, and we know for a fact, all right, we know for a fact that this thing is gonna be less. All right, let me recompile this entire thing. So rolling buffer plus rolling buffer size. This one has to be IMHTTP. All right, so now let's bring back .main and let's enable handling the body. Oh my god, yes. Okay, I finally refactored everything to have rolling buffer and the user buffer, and it looks all right. It's a little bit janky, but I think it's already better than we had before, so it's definitely an improvement in terms of like memory management. But the fact that I have to like wait until I handled everything, like the fact that I have to change this this condition to something else, actually kind of unsettling. Right, and I'm not sure what to do about it. I'm really not sure what to do about it. Right, so basically you're only allowed to read if you handled literally everything. Otherwise it's like, yeah, it waits until you have something. And I guess it kind of makes sense, maybe. I don't know. So I don't even know what to put into doing here. Maybe I'm gonna put the following to do. Document that does not perform any reads until everything inside of rolling buffer is handled, is processed rather, so because we're processing this data. Right, so all right, maybe it's a reasonable solution, maybe it's not a reasonable solution, I don't know. And let me make the pull request, so it's going to be rolling buffer, right. Introduce the rolling buffer memory management strategy, right, and let's push that right into the repo. Do we have a CI? I think we don't have a CI for this kind of thing. Okay, but I'm still having a habit of you know, of making pull requests to my own repos just in case. Just like, at this point it's a habit. All right, so hopefully this entire thing will make it easier for us to implement chunked encoding. So yeah, okay, let's actually merge it and let's try to implement chunked encoding. So we need something to test chunked encoding. I remember that there was a pretty cool testing page, transfer encoding, chunked test. This one, as you can see, I already clicked on it. So it's actually pretty cool. So as you can see, when you open it, it just gives you this chunk, and in 100 milliseconds it gives you the next chunk. So we can test like chunked encoding with this page. And because of the progressive rendering of the browsers, you can clearly see how it just loads the rest of the stuff, because the browser can actually display unfinished documents, right? I can even show you something cool. If you curl this entire thing, you will clearly see that the encoding is chunked. So we received like part of the document, and then we received the actual thing in here. So okay, that's pretty cool, and I want to be able to actually handle this kind of thing. So all right. Chunked. So I'm gonna gonna go to here, and I suppose in the main structure, I really like how small this structure became. So there's no like bloat in here. There's only two buffers, the rolling buffer and the user buffer. And you basically just find something within rolling buffer, you move it into the user buffer and give the user link to this buffer and continue processing. There's like two buffer strategy. All right, so we have a content length, and another thing that we probably have to have here is the chunked flag, right? So essentially, if we encounter chunked transfer thingy, we essentially enable this flag, we put it to true, and as you receive the next body chunk with this function, we're gonna assume chunked encoding rather than not chunked encoding, right? Makes sense as far as I can tell, hopefully. Anyway. So maybe we also should keep track of the size of the chunks. Okay, as far as I know, let me actually give the link to this website in the description. Chunked encoding testing page. Okay, so I'm gonna put it in here. And so transfer encoding chunked. This one. So the format of this thing is actually pretty straightforward. So the body is a sequence of these chunks, and each chunk starts with the size of the chunk in hexadecimal. For whatever reason, I don't know why it is in a hexadecimal, but it is what it is, separated by /r/n, and then comes the chunk of that specific size, and then /r/n, and then another one, and all of that ends with an empty chunk with the size equal to 0. Pretty straightforward. Pretty straightforward. Okay, so chunk encoding testing, chunked transfer, HTTP chunks format, right? And I want to actually give you the example pointer to the encoded data, something like this, because I think this one is quite important. HTTP chunks format. All right. Okay, so I'm HTTP response next header, right? Next header. And as we're handling the next header, I suppose we need to check for the following thing. It's going to be name must be equal to transfer encoding. So I actually spelled it correctly. And here is the interesting part about that. So you can have several encoding actually listed, separated by comma. So we also need to take that into account. So let's do the following thing. So we can have encoding list, and we're gonna just take the value and assign it to here. And while encoding list is not empty, it's greater than 0, we're gonna do string view encoding sv chop by delimiter encoding list. Right, this is gonna be encoding list, and we're chopping it off by comma. Right, we're chopping it off by comma, and we also probably want to trim this entire thing just in case, right, because it may contain like extra spaces and whatnot. And if this thing is equal to chunked, we said I'm HTTP chunked true. We just detected the chunked input, and yeah, we're gonna set it chunked to true. And all of that is completely transparent for the user, right? So the user doesn't even know that there is like chunk transfer in place, so they don't know anything. So another thing, so when we start the response, I'm HTTP res begin, right? We should also reset the state like chunked to false, right? So we reset the content length, and we also reset chunked to false. Cool. Cool. All right. So, does it compile? Hopefully it compiles. It doesn't compile because it's a C. Alright, looks cool. Now when I'm handling the next chunk, I suppose if we are in chunked mode, we have to handle everything completely differently. Right, so let's actually do it like this. If I'm HTTP chunked, right, we're gonna do one thing, otherwise this entire thing goes into like a separate branch completely. It goes into a completely separate branch. There we go. So all that should be like in a separate method, but I don't know how to call that method, so it is what it is. So what do we do now? We need to know whether to expect the length of the chunk right now or the body of the chunk. So what are we expecting right now? What precisely we are expecting right now? Top. So I guess first of all we want to kind of sort of like top, but we still don't know if we finished or not. We still don't know if we finished because, man, hard. Maybe we should have some sort of a flag that indicates that we finished. Boolean chunked done, and if we're done, we basically ignore any next read calls and always return false. If that's one of the things we want to do. Next body chunk. Actually, this one chunked done. It's going to be false. Next body chunk. If I'm HTTP chunked done, if it's not done, we're going to do that. Otherwise, we instantaneously return false. If it's not done yet, we need to take the chunk length. Right? If I'm HTTP chunk length, and do we even keep track of the chunk length? I think we need to do that. So let's go. I'm HTTP. So and this one is going to be something like to size t chunked length. Right. So this is the current chunk length. Res begin chunked length. Length is going to be 0. Maybe it shouldn't be called chunk length because it's the length of the chunk, so it should be probably called something like chunk length, not chunked length. Right, if chunk length is equal to 0, we need to expect the chunk. Right, expect get the length of the chunk. Right. And then get a bit of the body of the chunk. Right. All right, that's very interesting. So, but before we're gonna do all of that, we need to top it a little bit. HTTP top rolling buffer. I'm HTTP, so there we go. We have a little bit in there. If the chunk length equal to 0, we need to parse it essentially. Right, so we take string view rolling. I'm HTTP rolling buffer as sv. Right, and then I'm trying to get the chunk length sv chop by delimiter. I'm chopping this stuff by the delimiter. Rolling new. Alright, and we want to assert it yet again. So chunk length, if it doesn't start with /r, that means there's something wrong. If it doesn't end, so sv ends with, right, if it doesn't end with r, there's something wrong. That means the buffer is too small, or just like something terribly wrong. So, and the fact that we have to repeat this kind of check is actually rather interesting. That means maybe we need to extract that somewhere. The rolling buffer is so small that it could not fit the whole chunk length, or maybe this the chunk length was not fully read after h2 above. Alright, so that's basically what happened in here. After that, we need to save the chunk length, so it's going to be HTTP chunk length, and we already have a way to convert SV to U64, but we don't have a way to do that for hex. Right, so let's actually implement that. So it's going to be something like this, and it's going to be chunk length SV, and there we go, we have a chunk length. And after that, I suppose we need to do IMHTTP shift rolling buffer, and we're shifting it according to rolling data. There we go, now we have the chunk length. Interesting thing is that if after that the chunk length is equal to 0 again, that means that's it. We at the end of the transfer. So what we need to do in here, we need to say something like HTTP chunked done true, and instantly return false. That's it. There's nothing much to do in here. There's nothing much to do in here, and all right. After that, we know for a fact that we still wait for a little bit of a chunk. So yeah. We just need to read that chunk and return it to the user. How are we going to read that chunk? This one is actually very interesting. So since we have the length, right, since we have the length, we can use that length, right? We can essentially use that length. So we can have two situations in here, right? If I'm HTTP chunk length is less or equal to the HTTP rolling buffer size, right? So chunk length is less, that means the rolling buffer actually contains more stuff, or otherwise it could be actually greater. Right, maybe we want to invert that, right? So it's actually greater. So we can just consume the whole rolling buffer. We have to be super careful because rolling buffer contains the edge of the chunk, right? So here we can just consume the whole buffer, but here we are at the edge of the chunk, so we have to be very considerate. So in that case, what I can do, I can just I suppose shift the entire thing. So I'm gonna do I'm HTTP shift rolling buffer, and I'm just doing HTTP rolling buffer plus its size, right? So that will move the whole buffer into the user buffer and return us the chunk. So So it will return as the chunk. And do we check for, yeah, we do check for the chunk. So string view data, right? And if chunk was set, we just do chunk data. All right, so that's pretty straightforward. That's pretty straightforward. So, and here we have to be a little bit more careful, right? We have to be a little bit more careful. We cannot just consume the entire thing. What we have to consume though is the chunk. Yeah, so after that also we should not forget to do I'm HTTP chunk length minus rolling buffer like this. Right, we have to chop off one like a little bit of that stuff. Here we also have to shift it, but we have to shift it a little bit more careful. So since the chunk length is smaller, right, we'll have to shift it by that thing. And what's interesting is that in this particular case, we just assign chunk length to 0, and this is pretty much the same code, right? It is pretty much the same code. It's just like there is some sort of like a min-max situation in here, right? So maybe we're gonna do something like this size. So if chunk, so basically we're taking the minimum between these things. Yeah, this is essentially minimum, right? So initially this thing is going to be right, and if n is bigger than this thing, right, we just do n, so we take the minimum, right? So this is the minimum, and then we can take this entire thing and put it in here, and we add n in here, and then we subtract the n. There we go. So yeah, and we can remove it. You see, I'm a little bit tired right now, that's why I'm like I'm doing everything in a very dumb way. I really apologize for that. Right, so cool. That is cool, that is cool. All right, so we read the whole chunk and we return it to the user. Right, in both of the branches actually here. Oh yeah, and I forgot a pretty cool thing is that when you reached here, you have to automatically return true. Yeah, you have to automatically return true. So both of the branches contain return false. So we're gonna move this return false in here, and let's just put it like that, and everything seems to be okay. Everything seems to be okie dokie, karaoke. All right, so let me try to compile this entire thing. So macro assert above 2 arguments. I see. What else do we have in here? Passing, yeah, I'm HTTP, so that's what we're passing in here. Undefined reference to, yeah, SV hex to U64. Okay, so let's quickly implement that. SV C. So it's kind of similar to this thing, except U64T. String view SV. This one is interesting. It simply ignores everything that is not a digit, which is fine, I guess. All right, so we're going to be iterating through everything. Well, that's interesting. So it stops when it encounters first non-digit. Okay, that's a very strange logic, but okay. Okay, so we count plus I. All right. So we want to actually save this thing maybe somewhere here. So it's going to be x sv data I, and if x something like this, x less than 9, what I'm doing in here essentially is just I do result multiplied by 60 plus x minus 0. There we go. That's essentially what we have in here. Otherwise, if we are between small a and z, we do something like a but plus 10. There we go. The same goes for capital ones. We use the capital ones in here. And otherwise, since we stop at first non-digit, maybe we're gonna maintain the same logic. We just return it. I don't know why I decided to do it like that, but I mean, it's better to be consistent. I suppose it is better to be consistent. Okay, u int 64 and seems to be compiling. Okay, that is very, very interesting. So how much code have I written so far? And so implemented a bunch of stuff for the chunked stuff. All right, let me check if the current code with non-chunked encoding works. All right, seems to be working. Okay, so let's actually grab the testing page. All right, so this is the testing page. We don't have a URL parsing, right? We don't have a URL parsing, so I'm gonna just change the host to this. Here's the host. And the resource to chunked. What the hell is a chunked? Chunked. So where is the resource? Here is the resource. I wonder if it's gonna work or not. We'll see, we'll see. The winner gets T, that's for sure. Okay, well, I didn't recompile it, of course. Okay. Of course. Yikes. This one was interesting, actually. So transfer encoding was fine, and then we stopped at some point. That is really strange. But look at that. We received the first chunk, but we didn't receive the rest of them. That is really, really strange. Okay. Why didn't we receive the rest of them? Is it because the rest of them were 0? Or what exactly happened? Chunked is not done. Let me see if I actually zero out everything in here. Alright, so res begin. I seem to be zeroing out everything every time I start, so chunked length, next body chunk. So if it's chunked and it's not done, chunked and not done, we top it off. If the length is equal to 0, we try to parse this entire stuff. We take the length. Maybe the length was fucked up, actually. Let's actually try to print it. Who knows, maybe I fucked it up somehow. So LD, let's just copy paste it. It would be better to actually go into the debugger. You know? But I mean, 1, 2. So there was one. Well, that's so derpy. Okay. So it has to be new lines in here. So we received 127, and the next one was actually 0. That is strange. We literally received like a 0. What the hell? So one was 127 and another one was 0. Extraordinary. So, and because of that, So we also shifted everything. We always shift everything, don't we? Then we do. Chunk length, if it's bigger than this thing, we can set it to that. It's becoming 0. We're going to try to do that yet again. That is really strange. One of the things we want to do, maybe let's actually try to debug this entire stuff. Let's try to debug it. Okay, let's break this entire thing and let's just run it, and let me take a look at it. So if I print the IM HTTP rolling buffer, what do we get in there? So we have 7F. We actually have, well, I mean, it depends on the size, because we probably have a lot of garbage in here. Yeah, 133. All right, so we try to top it. We can actually look into that, and as you can see, yeah, it was completely ignored. So HTTP chunk length, right? So here it is, it's 0. Then I take the rolling and then chunk length. I can try to print the chunk length. Looks good to me. Right, everything seems to be fine. When we print HTTP chunk length, right, it is that. Let me take a look at the buffer. So I'm HTTP rolling buffer does contain this thing, right? And after I shift it, one more time, it didn't shift it. Okay, I found the bug. What happened? You top the rolling buffer, you take it as a SV. Why it didn't shift it? Why it did not shift it? Should have actually shifted it, but it didn't. So I'm just looking at it, and this thing is still there. So hopefully I'll find it soon. Maybe it depends on what rolling data is equal to. Well, I think it's pretty correct. I think, in my opinion, it is pretty much correct. Don't see any problems with that. But it did not perform the shift. We can try to go inside and see what's going on there. Right, so, all right. Next body. All right, so let's break. Oh boy, oh boy, oh boy. Okay, let's run it to enable, and let's go inside and let me print the I'm HTTP rolling buffer. Here's the rolling buffer, and if I print rolling now, and yeah, so if we need to first chop it, and it seems to be chopped correctly, then I'm gonna go inside of the shift rolling buffer, and it didn't go inside of it. Is it because it just, what the hell is going on? You know what? I think I forgot to recompile my program. Shit. Okay, we're almost there. We're almost there. All right. Break. Run it to enable. Okay. So let me print. buffer, here it is, and then I'm gonna make a couple of steps in here, and I'm gonna take a look at it one more time. Here is the beginning of the chunk, and then I'm taking at the rolling, so the chunk is chopped off, right? So then I'm looking at the chunk length. Here's the chunk length, and rolling buffer does contain the length now. It does contain the length, and I'm going to be shifting it. And if I take a look at it one more time, it's been shifted. Okay, nice, cool. So this thing is not done yet. So what we're doing here, we take the chunk. So, and the size of the, okay, so n, and the size of the I'm HTTP rolling buffer size is actually a little bit bigger, so that means it contains something in there. It contains something in there. All right, so let me take a look at the I'm HTTP rolling buffer. So we shifted it, right? So I think we pretty much shifted it. And the size after shifting it, I'm HTTP rolling buffer size is 2. So we only have like this /r/n. Oh, by the way, I think I forgot to do that. I forgot to handle the situation that chunk ends with /r/n. I completely forgot about that. That makes sense, and this is precisely what got left in the buffer. In the buffer, we only have 2 characters, and this is 2 characters, /r/n. So we need to handle that situation somehow. Cool, thank you very much. Okay, thank you, Debugger-sama. All right, so let me go to HTTP, and here is the cool thing. Right. Where are we gonna handle all that though? So I'm not sure. I have a cool idea actually. What if we add +2 to the chunk? And then it automatically will include /r/n, and you'd supposed to actually, well, I mean, how the user knows that it needs to remove these 2 things, I don't know. I know, man, I know. So here's the thing, we're gonna say that the size of the chunk is +2, and if after handling all of that, your length if I'm let's actually put it this way, if I'm HTTP chunk length equals 0, right, we're gonna do chunk count -2. Because we know for a fact that there's an extra 2 characters, so we're gonna just like trim it off a little bit, and we can also assert that this thing is greater or equal than 2 at least. So that's an interesting hack, because I'm too lazy to handle that. So let's just say that the chunk length is always gonna be like at least 2. All right. And fuck, and now this kind of situation, this kind of shit doesn't work. Fuck. Okay, so I think it's a bad idea, because this condition breaks now, so it won't stop reading the chunks. Okay, but that was a good try, I think, in my opinion. I think it was a good try. So essentially, after we read this chunk, and right, and the entire stuff, was shifted, and so the chunk length became 0, right? If it became 0, we have to shift these 2 characters. Maybe we need to have something like I'm HTTP shift rolling buffer. So we got into the situation then when sometimes some data needs to be just dropped without transferring the ownership to the user buffer. So this is the situation that we got. Sometimes it needs to happen. That is very interesting. Why do you need /r/n at the end of the chunk when you know the size of the chunk? It's like, what's the point? It actually makes everything complicated. Like, if we didn't have /r/n at the end of the chunk, like, it would just easier to handle. Because we already know the size, what's the point? Goddamn HTTP, I swear to God. I don't know. So we can assume something that string view rolling, right? I'm HTTP rolling buffer. I'm HTTP. There we go. So here is rolling. And if rolling, so we can assert that rolling starts with /r/n, right? So this is one of the things we want to assert in here, right? And then we need to have something like HTTP drop rolling buffer. Right, so it's going to be I'm HTTP, and we're going to say we're going to drop 2 characters in there, right? So that's the thing we're going to do in here. I wonder if sv.h have starts. Yeah, we do have starts. That's nice. So we will need to drop rolling buffer, shift rolling buffer. So this one is going to be static, and I'm HTTP, and it's going to be just n. There we go. So first thing we want to do, we want to assert that I'm HTTP rolling buffer size is well, n is smaller or equal than this, right? Smaller than equal than this. Then what we're essentially doing, we're just doing mem move. I'm HTTP rolling buffer plus, yeah. So this is the destination. The source is that plus n. And we're copying n of these things, and then we do we decrement the size of the buffer. There we go. This is how we're going to be dropping all of that. Is it compiling? It does seem to be compiling. Okay, so essentially, when we reach the end of the chunk, we just look if we have these 2 extra characters, and we just drop them. Right, we just drop them, and that should be enough, at least for now. Let's give it a try. Let's see if it's gonna work. Interesting. I think it worked. So there's a 31. Do we do a printf of the length somewhere? It feels like, but overall, look. It kind of worked. It waited and then received the. Sometimes it just returns this weird thing. Why did it return a bad request? Did we send something to it? I don't think we sent anything to it. So just maybe it's because of some keep alive stuff, but yeah, it just waited and then we received this entire thing. That's actually pretty cool. Chunk length. Let me see. Do we print this shit anywhere? It feels like that we're trying to print it somewhere. We actually don't, because what the hell is 31? What the hell is 82? Do we actually have anything like that in there? I didn't think so. No, I didn't think so. Something is borked. Something is definitely borked. And I don't really know exactly, but it roughly works. If you think about it, it roughly works. If it's 0, we take a look at the rolling. Right, if it starts, we need to assert that it starts with /r/n, and then we drop this entire thing. Okay. After that, should be alright. I don't know what the hell is going on. But... So do we have any printfs? We don't even have any printfs, so I don't know where this shit is coming from. Maybe we have something in here. No, we don't. So we just received the chunks and nothing special. The server should not close this stream before all chunks are sent to client. That's actually interesting. It feels like we're printing the sizes of these chunks, but I don't remember doing that. Oh, this is because I never actually recompiled any of this shit. But still... Man... Sometimes it works. Look at that. It just worked now. Right, it just worked perfectly, but sometimes it doesn't work. Now it works. It doesn't work now. Sometimes something goes out of sync, but overall, okay. I don't know what exactly goes out of sync is there, but it's not fully like it's not always reproducible, and I don't really know why it is not always reproducible. It's because something might be actually going out of sync in there. Why sometimes we receive this 31 and 82? What is the 31? Why do we receive that? Is that the size of this thing? It's actually 49 character, and if I do something like... Yes, okay, so this is literally the length. We for some reason we're handling the length. We're getting the length in there, and I don't know why. We shouldn't be getting that. We shouldn't be getting that, but we're getting that. So if it's a length equals 0, we take a rolling /n/r, and this is what we got. We might as well just do SV trim here. I don't know if it's worth doing, but we can try to. Maybe I implemented something here incorrectly, but I'm not sure. God damn, but sometimes it works. Like it's really strange that sometimes it's just like you see it works, sometimes it doesn't work. It would be nice to know why precisely. I have an idea. What if I do something like assert false in here? Well, sometimes it works, sometimes it doesn't, but I don't really know why. But overall, I think we got closer to the chunk transfer encoding. And you know what's cool is that the interface of the library hasn't changed. The interface of the library hasn't changed, is that just sometimes it just crashes. Okay, let's actually try to reproduce it a couple of times. Now it's not reproducible. And sometimes, yeah. Sometimes just like with a different timing, we might not be receiving like all of the chunks or something. Maybe we actually receive them split in different fashion or something. So maybe one of the things we want to do, we want to actually display the chunks that we're receiving, right? That's one of the things we can do. But overall, I think it's kind of a success. It's just like we need to understand what precisely is going on in here. All right. Implement the chunked transfer encoding. Right, so we actually implemented it, but it's a little bit buggy, right? But it needs to be actually debugged a little bit more. And it fires up, sometimes it fires up some of the asserts, but sometimes it doesn't. You know what's cool is that it doesn't really suck fault. That's what's cool about this thing. It doesn't really suck fault. It primarily hits the asserts, which means that it's relatively safe, I suppose. I don't know. So, oh shit! Wait a second. Sometimes it actually, okay. Yeah, I don't know what's going on here, but maybe we can actually debug it a little bit later. All right. Sometimes fires the asserts. Right, so this is going to be a separate to do with which we can work separately. Add to do for failing chunked encoding. All right, so we implemented like a little bit of a chunked encoding, which works relatively well. It's just like it's not clear what the hell is going on in there, but sometimes, as you can see, it works. Right, so sometimes it works, sometimes it doesn't, and we receive one chunk, and then after some time, after 120 seconds, we receive another one. That's precisely what we want to see. Sometimes it fires up something, but that requires a little bit elaborate troubleshooting, and I'm a little bit tired already. So I guess I'm gonna call it a day. So today's stream was actually pretty productive, not gonna lie. So let's actually create a pull request and merge it, even though I don't have any CI, but I still have a habit of doing that. All right, compare and pull request chunked encoding. Chunked encoding. All right, so we also did a pretty important thing in here. We changed the paradigm of memory management. So now we have two buffers, the sort of like a rolling buffer into which we receive the input, and then the user buffer into which we put the data that will go to the user. And then constant rolling around, actually a little bit better than we had before. Maybe that thing is also a cause of the problems we have with asserts and stuff like that, because maybe the buffer cuts off like in between of /r and something wrong is going on there. It feels like sometimes the length, chunked length, is not parsed properly, so it's very strange. Okay, so if it's zero, we take the rolling, we split it by n, so that means that length I have to have /r in there. We're trimming this entire thing, and we converted it into chunk length, and then we're just shift rolling the entire stuff, and the entire stuff actually points after this thing. Right, it points after this thing. If this thing became 0, that means we're done, we return false, bye-bye. Then we take this thing, if rolling buffer size currently is greater than this chunk length. So we set the rolling buffer to that. All right. If chunk length after that is equal to 0, so this thing never fires for us at least, so maybe that's fine. Maybe this one is not implemented properly. Right, so this is the destination, this is the source, and this is how many things we copy, and then we subtract this thing. I don't see any errors in here. So yeah, I'm gonna troubleshoot that a little bit later. Yeah, you see, sometimes it fails. Sometimes it fails. So, and when it fails, it actually starts printing the length of the chunks. That means the chunks sort of go out of sync, if you know what I mean. They sort of go out of sync. All right, that's it for the day. Thanks everyone who's watching right now. I really appreciate it. Thank you for all of the support, for all of the Patreon and Twitch subscriptions. It really means a lot for me, especially when I'm on vacation. And yeah, check out the description for all of the links, all the projects and stuff like that. And I see you all tomorrow. Love you.